Pythagoras theorem recap. So we know this is called what?
Hypotenuse.
So that's the hypotenuse. We know that a squared equals b squared plus c squared if a is the hypotenuse. Okay, so remember, it's not so much a, b, and c, what's a, b, and c. You just have to remember that whatever the hypotenuse is, that's what it's going to be equal to. Yeah?
Wait, can we use it your method where we're figuring out what?
Yeah, totally. Yeah. So here it says find the missing length in each of the following triangles. So for this one, we say, are we finding the hypotenuse or a short side? Hypotenuse, so let's put it x. We would say that x squared would be equal to 12 squared plus 5 squared because it's a long side that we're finding. And then x would be the square root of that. Yes.
So 13.
Not to try and find the length. No.
So then, it's you try to find like zero finding when you have it.
If you have two lengths and you need to find a third length, that will always be Pythagoras. So is it always involving an and?
If you're using an A.
The question, the word involves that. Yes. Girls. Because the sine, the cos, and the tan has to be attached with the angle, yes? So that's why they involve that.
Now the answer is 13. Okay, but what's the thing on squared?
That says 12 squared plus 5 squared.
You just did it all in one.
Oh my god, it says 12 squared plus 5 squared.
I thought it said 1, 2, 4, 5 squared. I didn't get it.
We're all quite picky when it comes to writing. Maybe I should start having a look at your writing. Okay. So, I always start with my unknown, so I'm starting with y squared. Jodie, am I finding a short or long side? Short side. So later, what does that mean that my equation is going to involve? A subtraction. Good. So what am I going to write? Y squared equals? I was kind of going with later, still saying stuff, but that's okay. You said it nice and loudly for her. It's totally what she was going to say anyway, wasn't it? So y is going to be the square root of 10 squared subtract 8 squared. Look, I'm writing a lot nicer now. So, oh, thank you, kindly. Gosh, I feel there's a bit of aggression there. That's okay. That's okay, next one. Anyway, are we finding long or short? Short. That means we're going to be... Okay, what letter should we use?
A.
B. N. A. B. X. Why don't you choose X for Oh, X is what we have. So we have got p squared is equal to 10 squared subtract 6 squared. 8. Thank you. Go, Laura.
The next one is B.
R.
Oh, the next one's B.
Yeah.
Oh
my gosh. I said Q. Did you call it Sasha? You can call it whatever you like. I'm going to call mine forever, actually. Now, there is one, I'm giving it way too much, actually. There's one slight difference with this one. Ladies. This measure is in centimeters, this one's in millimeters. If you're doing questions like this, you need to watch out for that in case they're sneaky and do that. You need to put them in the same unit. It doesn't matter if you put them in both centimeters or both in millimeters, but you have to pick one. So you need to know your conversion. So I'm going to get rid of my decimals if I can. So I'm going to change this value at the top to be in millimeters. So 2.5 centimeters. 25.
You just times by 10, right?
Correct. So I would, again now, so now we've got the same units. Ashley, Stevens, what will I do now?
Q squared equals 25 squared.
what is, Q is a long or a short side?
Short.
Short. So we're going to be subtracting. So we always start with our long side. Yeah. So it's going to be 50 squared.
Subtract 25.
Good. If you had tried 25 squared, subtract 50 squared, you would end up with a negative number, and when you try to square root it, it will tell you it's wrong. Okay?
No, Avery, it's not the right step yet. It's not the right step yet. 43.3 millimeters.
I'm very appreciative of everyone this side.
Is there anything smaller than a millimeter?
Yes? Could you just... So, now into the 3D. Now, as you can see, this is often how 3D diagrams are drawn on paper. They've been challenging to draw. And so, to show that it's clearly right angles is often challenging. I keep saying the word challenging. Shut up. Okay, I just heard it. Sorry. Now, if we have these kinds of things, it's often useful if the question hasn't done for you to label your vertices. You know, a vertex is a corner bit, yes? So you can label these vertices, that's plural vertex, with letters. Doesn't matter what letters you use. Okay, so we've got A, B, C, D, and E, F, G, H. Now that also enables you to talk about planes. So this would be a face or a plane. This would be a face. Okay, so you can talk about the face C, G, H, D, and so on and so forth. So, as I said, labeling each vertex with a letter can often help if they haven't done so already. So here we go. We are. Oh, we haven't even said what the question is.
There are
All right. There are no questions. Right, in this question, we're asked to find the length BH. Okay? So what we're having to do is imagine a line going from this corner up here down to this opposite bottom corner. So in this situation, it would be like this. Okay? So I've gone from my corner up here down to the bottom one through the shape. Okay? So we have to say to ourselves, right, that means, oh look, I've done it here, that I need to drop my line from here to here, and then join that up to H. That's going to form a triangle. Now, you're not necessarily going to say immediately, oh, that's a right angle triangle. But the nature of a cuboid means that we should recognize that this base meets any of these uprights at 90 degrees. Yes? So this line here has to meet this one going on the bottom at 90 degrees. As I said, some of you might be like, yeah, that's easy, obvious. Others could be like, but that doesn't look like 90 degrees. I'm never going to think that's 90 degrees. So this is one of those things that you just have to practice. If necessary, assume. I hope you're right. Okay? So here, that would be my new right angle triangle. Now, that's all well and good, but depending on the information they've given you, sometimes you would need to think about this length here on the bottom. So if we were trying to find this length here on the bottom, and we didn't know it, but we did know these two lengths, again, whilst it doesn't look like one, that is actually a right angle there, so that would be another right angle triangle. Wow. And so, as I said, it's like the white one here. Can you all see that one? So it's going along the center of the cuboid on there, but it actually is a right angle triangle if you were facing that bottom.
So we just assume when we make triangles in here, it's always going to be right angle triangle because there's right angles everywhere.
Majority, yes, but you need to identify where the right angle is.
Aren't they just every corner?
Yeah, so it will be from side or to the floor or from side to another side. Yeah? Yeah. Okay? So, as I say, a lot of people, they look at diagrams like this, and as I've said, I've shown this one here, like this. That's how it was drawn here. But actually, it is a right angle triangle. Now, the reason I say about labeling is because it does mean that you can just rewrite them looking how it should be. Okay? So, this is a This is a prism. Okay, do we know what a prism is?
No.
What's a prism?
A rectangle that's 3D.
Not always a rectangle.
A shape that is shading.
So, a prism is a solid that has the same face front and back. Okay? So, for example, a cylinder has a circle on both ends, and it's the same circle all the way through. So that's a prism. Okay? Like the Toblerone box. That would be a prism because we've got a triangle on both ends. A carrot is not a prism because it's got a big circle at the end, and then it would go down to a tiny circle. Yeah, a cucumber is more of a cylinder or a prism because ideally all of the bits. Because it's not really a cylinder.
Like how you
Yeah, most of the circles are the same size.
So if it's all just the same shape all the way through.
Yeah, so it could be some random shape all the way through. As long as it's the same shape both front and end and it's the same size, this would be a prism because they're both rectangles or squares at either end.
Okay.
Yeah?
So what is the prism? So a cucumber is a triangle. No,
Cucumber is kind of
not
similar.
a cucumber.
Yeah. All right. This is not a prism.
so hard to pick up.
Yeah.
How do you know which is front and back? Like, a soccer ball has all the same size, I'm pretty sure. Don't tell me on that.
That's a ball, darling. That's a sphere, so it's not prism.
But it's got a bunch of shapes on it.
Yeah, the shape
But it doesn't, because that's what I said. A prism has the same face, front and or either side. Whether you're holding it like that or like that, if it has opposite faces that are the same shape and size, then it's a prism.
It's just your football does have that.
No, it's
No, a sphere is different than it has one face. You need opposite face.
I know, but the ends don't get bigger. You need it both the ends are the same size.
6
Yeah, that's all the way through. That's what I said. The same end and all the way through. Alright, okay, so after that fight,
I just answered a fantastic question.
I'm sorry, Dan. Hello?
I just answered a fantastic question. So Laura asked, is a sphere a prism? And I said no, because it doesn't have more than 2 faces. Because you need at least 2 faces.
It has one face.
No.
How do you do the net of a sphere?
So the sphere.
You know the net where you, like, take the
Yes.
yeah? How do you do that for a sphere?
We don't. Let's not go sidetracking, please. Can we get on with this? Right, so this is a prism. The end faces are squares, so they told us that they are squares. We know squares have equal side lengths. And they told us those sides are 8 centimeters. The length of the prism is 15. So we know that these bits here at the end are 8. So this. If you want to label all of them, you can. And I know that this bit here is 15. If you wanted to label those two as well.
So are these diagrams drawn more to scale?
No, again, they wouldn't be drawn to scale.
But 15, the line 15 looks bigger than the one 3. So, like,
Well, they often do that.
so like, yeah, but you don't know the length, you just look at the bigger one.
Sure.
Where's the triangle?
I'm going to draw it in.
We're trying to.
Wait, what about the length?
We're looking for the
Oh,
angle.
Laura.
Okay, oh my gosh. So, they have square ends. So the DCGH is a square. So that's why I've labeled both of those to 8. I could label these to 8 as well, but I think that may just confuse the diagram slightly. I've labeled both of these 8 as well because they said that both ends are a square. And they said that the length of it, which means the distance between those 2 faces, as 15. Obviously, all of these 4 lengths would be 15. If you want me to label that one as well, just to make it feel better. So they would all be 15. Okay? Now, our question hasn't asked anything yet, so that's why we've got no triangles yet. So it says, find the angle between lengths EG and CE. So EG. So So EG is going diagonally through the center.
EG?
And CE is going through the cuboid. Okay, so EG goes diagonally along the base, and EC or CE goes through the solid. Now, I've said here, firstly establish what you're trying to find. So we've got this angle here that we're trying to work out. I'm now going to redraw that triangle, and I'm going to label my vertices. So this point is going to be E, and that's where my angle is, yes? My top of my triangle is C, and the bottom is G. Are you all comfortable that that is a right angle triangle?
Yes.
Okay? There could be some of you thinking, is it? I'm hoping not. So because this is the base and this is the side, we know that has to be 90 degrees. It doesn't look it, but it is. Right, so now I'm going to label any measurements that I do know. Well, I know that CG from my diagram is 8. I don't know EG because that goes through the middle, and I don't know EC because that goes, through the middle of the base, and the EC goes through the middle of the cuboid, so I don't know that either. And obviously we don't know the angle because that's what we're trying to find. But, so now what we need to do is try and work out either EG or EC. Now, we look at the diagram again. We're looking at EG or EC. Now, hopefully you can see that EG is on the base of the rectangle, and I know that this measurement is 8 and this is 15. So what I can do now is label this G, this E, and this H. That would be 8 and that would be 15. And that will allow me to calculate this length EG that is one of the ones I'm missing. Because it's from E to H.
Okay, now you don't get it.
Yes?
I was just told you, but the angle is here?
Yeah, we haven't got to that because we need, in our diagram here, in order to find this, calculate this angle, we need to know 2 lengths, and we don't. So we're having to do extra work. So, we would find EG, so EG squared would be equal to, now is it the long length or short length?
Short, long.
Long.
I'm trying to figure out. Sorry.
EG is the long length, it's opposite the right angle, so it's going to be 15 squared plus 8 squared. So, 17. So we know that EG length is now 17. So we can transfer that number now into my original triangle.
I love this game.
It's Emily out. So why did you choose tan, madam? So we label our H, O, A. H is useless to us. It's O and A, so Emily's chosen TOA. We're trying to find the angle, so we always cover up the first letter. So we would say tan of theta is opposite over adjacent. So tan theta is 8 over 17. Theta is tan to the minus 1 of 8 over 17.
25. Miss Harrison.
25.2. Was I supposed to write all that down below?
No, good question.
I'm just checking. Yeah. Yes, madam?
I'm so lost. The EG, how did you put it as a hypotenuse?
Okay, so I visualized, I saw EG was on the base, so it's basically the white triangle.
Oh, okay,
I
I see.
Yeah?
I see now. That's so ironic because then you couldn't. And yeah, that was good.
Okay? Are we all good? Yes.
So I don't.
Because we didn't have those.
Oh, we don't need the hypotenuse, we need the angle. The question asks us about the angle between them. Yep. So in order to find that angle, we have to know another length. Any length, but we chose that one. Tanya?
Why do you show it again?
Because remember, the rules are label HOA, establish which length is irrelevant. So because we knew that the length O and the length A, but we didn't know the length H for this triangle, we crossed that one out. So that meant HOA.
Someone talk about a bit of math tests. It's not awesome.
I'm going to let you guys have a go at these, and then we'll see if we get them right. So we've got 15 minutes. Let's try and okay. All right. So this should be the working. So we've got. They've asked us to EG, so we should spot that that goes through the centre of the base. Okay. And they've given us both the length and the width of that base, so we can draw our triangle here. So I've chosen H. You could have F there as well as your other letter. Either way, it would be 3 squared plus 10 squared and then square rooted, which I don't know what it is. 10.44. 10.44. So you should have 10.44 for EG. Then they've asked us about CE. So CE is the one that goes through the centre. I've dropped it down to G as my other bit. So then I've got CGE. I've just worked out EG, and that was 10.44. And so I can find EC by squaring and adding that with the 5. So I'm going to switch this. It should now be 10.44 squared. And what do we get when we square root that bad boy?
11.5.
11.58?
Yes.
Wait, what?
No.
Yeah.
Probably not.
We square and add. So definitely can't be smaller than 10.44. So we've got that then. Then I know EG. I ditched EG even though I forgot we worked it out. So I did CE. So I chose so. You could have had car or tower. So I'm going to have 11.58. And what do we get as our angle? Yeah. Isn't it 5 instead of 3? 5 instead of 3.
It was the second one.
Do you mean I've written 5?
Oh, sorry.
Okay. I do make mistakes, but I didn't know what you meant. I wrote 5. What is this angle here? What do we get? 25.8? Is that what we all got?
25.8. If you do 2 decimal 25.6. You need 2 times the decimal point.
When it says 3 6 it's at the very top of the question.
6 still would round to 8. So that's like the other numbers. Were you rounding it? Did you do 10.25?
You're wrong. I don't know, girls. Let's just chill.
It says 3 6 big.
So, it's somewhere around that. As long as we've got that, that's fantastic. Okay, so, we'll do the last one next lesson. So, I'm sorry, Lara, maybe you'll miss that, but I'm sure you'll catch up.